Okay, you're welcome to my class. I am Dr. Bankole Ojo Olufunsho Samuel. So, Lagos State University of Education, Department of Chemistry Education, and the course code is CHM312 and CHM322 with course titles Instrumental Methods of Analysis and Separation Methods of Analysis. Actually, my lecture today is titled Fluorescence Spectroscopy. But before I move into the core aspect of my lecture, I'll be delving into what fluorescence is first of all. So we'll look at what fluorescence is. So what is fluorescence? This is the ability of certain chemicals or materials to give off visible light after absorbing radiation, which is normally not visible. In other words, fluorescence is fluorescence. A fluorescent substance will absorb light, okay, or electromagnetic radiation, usually UV, and emit it as light. So what we are saying here is we have a material, okay, that for example you have the dollar note there. When you look at the dollar note, you normally not see this white visible light, okay. It's this line here. So this line is only visible because it is under UV light. You can see the UV light just below, okay. You can see that purple light there. You can see there, right? So because you are putting it under UV light, you can see that white light. This is one of the ways to authenticate whether the dollar note is fake or original. Okay, and it's done in many countries. Example, this is an Indian currency. Okay, so you can see under normal white light, look at how it appears. But under visible light, that's UV light, you can see a glow. So there you have Mahatma Gandhi glowing green. Okay, so you can see the green glow, and you can see the orange glow, right? Something like orange thereabout. So or pink. Now this is fluorescence because once you remove the UV light and it goes under white light, this glow disappears. You will not see this color again, right? So it comes back to this. You can see the difference. So the difference there is the fluorescence. So you have a material that is fluorescent, okay, on the note. So the material on the note, that's the fluorescent material that's been used to coat the note, will give off light when it is subjected to UV light. So once you put the note under UV light, you see new features appearing. That is how you know whether the note is original or fake. And actually, several of our body fluids also give off fluorescence. If you've watched some movies, you notice that maybe there during a crime investigation, okay, sometimes the investigator will darken the room and put on the UV light to take note of the body fluids on the walls of that house or room. So even our body fluids, okay, can also give off fluorescent light when it is subjected to UV radiation. So these are fingerprints, okay, and they can come in different colors. That's fluorescence. Fluorescence can be blue, it can be green, it can be red, right? Now, look at another important tool. For instance, fluorescence is also used for imaging cells. So this cell does not look like this under normal light, of course, but sometimes to see the content of the cell, a fluorescent chemical can be introduced into the cell, and the cell is placed under the UV light to produce a green glow. So this is where you have a green glow, okay, because the cell has been placed under UV light, and so you can see the contents of the cell, right? You can see the contents of the cell. So that's one application of fluorescence in the laboratory. So there you have, that's imaging. You can use fluorescence for imaging, okay, not just for counterfeiting. And another important application and where you see fluorescence is in diamonds. Okay, a lot of diamond retailers, those that sell diamonds, you notice that they have the UV touch, comes like a touch. Okay, and then when you bring your when you want to resell your diamond, you approach them. They usually take the diamond to a dark place, okay, and subject it to UV radiation. So this will usually give off fluorescence. You can see the difference between the diamond under white light and diamond under UV light. So you can see the glow. It glows blue, gives a blue fluorescence. So this is what fluorescence is. So you have to subject a material, okay, to an external radiation to get a fluorescence emission. So this is the fluorescence emission given off when it is subjected to UV radiation or UV light. Here it is under white light, here it is under UV light, so you can see the difference. So this is one of the ways to know whether the diamond is original or fake. Now this is a UV lamp. I have one at all. I have two actually. So two of these. So, and is a common UV lamp that can be used to produce UV light. Okay. Now that you understand what fluorescence is, we can now move on to fluorescence spectroscopy. So what is fluorescence spectroscopy? So note that so many materials in nature are fluorescent. Okay. So many of them are fluorescent and they are used for so many applications that we are going to be talking about. There are many applications ranging from security to what we call sensing. Okay, some like I showed you earlier, imaging of cells and the likes. Okay, crime investigation and so many things. In fact, in some countries, when the security agencies want to pay ransom to kidnappers, they usually soak the notes in a fluorescent material. Okay, so when they pay the ransom, they track the notes from the market and get and trace the notes back to the kidnappers. That is one way kidnappers have been tracked in recent times. So fluorescence is a very important phenomenon in the world today. Okay, in fact, for some animals and plants, it is used, okay, in tracking their movement because they can see in the UV region. So fluorescence is of immense importance, okay, all over the world in many applications. Now, when you want to determine the extent of fluorescence of a material, how are you going to analyze it? Okay, so that brings us to fluorescence spectroscopy. So for fluorescence spectroscopy, you are analyzing the intensity, okay, of the fluorescence of a material. That is what you're looking at. And now, fluorescence spectroscopy, the principles, the theory, the instrumentation, and the applications are the things I'll be considering uh, in this lecture. So that brings us to what we call the fundamental concepts. So fluorescence spectroscopy is a photophysical analytical technique based on the absorption of electromagnetic radiation by molecules, followed by spontaneous emission of light at longer wavelength. So first of all, this technique is based on what? Absorption of electromagnetic radiation. Remember I told you for something to fluoresce, you must subject it to an external radiation, right? Maybe UV radiation in the case of currency notes. So the technique is based on the absorption of electromagnetic radiation by molecules, followed by spontaneous emission of light. So for fluorescence, you must introduce maybe UV light, okay, for that chemical or material to produce its own light. So that is fluorescence. Fluorescence is different from phosphorescence. Phosphorescence is what you get when a material keeps radiating light even after the source light has been taken away. That's phosphorescence. Phosphorescence is different from fluorescence. So for phosphorescence, an example would be the Catholic rosary. I'm sure you are familiar with, some of you familiar with the Catholic rosary. You know, when you wear it and light goes off, it keeps glowing. You know, and for some of you that wear these wristbands, some of them also give off phosphorescence. That is not fluorescence, that's phosphorescence. So for phosphorescence, the the material will keep glowing even after the light has been taken away. When the light is no longer available, the material keeps giving off light. That is phosphorescence. But for fluorescence, the light must be there, okay, for the material to give off light. That's different. So you introduce light to it, UV light, and that will give off a fluorescent light. But phosphorescence, it is when the light has been taken away that it gives off uh, light, okay, and you now see it as a glow. So that is phosphorescence. So we are not talking about phosphorescence here, we are looking at fluorescence. Now, this is a subset of luminescence phenomena and arises from singlet electronic transition. We are going to look at that shortly. But yes, it is a subset of luminescence phenomena. So luminescence, we normally categorize it into the fluorescence and phosphorescence, as I've talked about, and I've distinguished between fluorescence and phosphorescence. Now, take note of this. Remember that when you have molecules, you can excite them from the ground state to a higher excited state, right? We are going to be looking at that, but take note of these three states: ground state, excited singlet state, and triplet state. I go over it again. So you have the ground state, excited singlet state, and the triplet state. Now, absorption promotes. So the first thing, before you talk about giving off fluorescence, remember there must be absorption of light. So like we talked about earlier, so light must be absorbed for fluorescence to be produced. So absorption promotes electrons from S naught to Sn. Sn can be S1, S2 or so. So first, when a material or a chemical absorbs light, okay, so the electrons are promoted from the in that chemical or on that material. So the electrons are promoted from the ground state to an excited state, okay, which the excited state we call it S naught to Sn. So it could, meaning that it can be S naught, it can be S1, it can be S2, it can be S3. Okay. So and we can see that in our diagram called a Jablonski diagram. A Jablonski diagram. So for a Jablonski diagram, you can see that we have S naught, the ground state, right? Then here you have absorption. So this is when you introduce light to a material. Okay. When you introduce light to the material, electrons are excited from the ground state to an excited state. So it can be from S naught. In this first arrow, you see S naught to S1. The second one, S naught to S2. The third one, S naught to S3. So this there you have excitation of electrons as a result of the absorption of UV light in case of many fluorescent materials or chemicals. So when the electrons are excited, okay, due to vibrational or due to vibrational rotation, so you have the electrons losing energy. They lose energy and then they fall back to the what ground state. So when they fall back to the ground state straight up due to in what we call internal conversion as a result of vibration and the likes, when they lose energy, they fall back to the ground state. So that means if it is in S1, it will fall back to S naught. If it is in S2, it falls back to S naught and the likes. But remember, they can also fall back, okay, stage by stage. But at the end of the day, they still fall back to what? The ground state. So when they fall back, okay, based on the singlet, this S1, S2, and the likes are singlet state. When they fall back following the singlet state, they produce what? Fluorescence. And that's why when you have a fluorescent material and you put UV, okay, introduce UV, it is nearly immediate that you see the fluorescence giving off. So it's very fast. And the reason it's fast is the electrons are quickly excited and then de-excited. That means they fall back to ground state. But for fluorescence, you notice that when light goes off, okay, that is when light is produced, and that is because you have some extra processes where it moves from the singlet state to the triplet state. So at the triplet state, you have the electrons de-exciting, that's losing energy, and moving to the triplet state before coming back to what? To the ground state. So that's where you have phosphorescence. So that is the Jablonski diagram. So remember you have the that's internal conversion IC for the fluorescence, but ISC occurs for what? Phosphorescence to happen. So take note of that.